Alright, in this video we're going to be doing some partial derivative examples. And this is just like a little worksheet that I typically give out after the AP exam for AP Calculus. And really what you need to know from the lesson is that when we're taking the derivative with respect to x, we treat y like a number. Okay, that's it. So df dx, okay, we know how to take the derivative of x squared with respect to x. That would be 2x. Okay, e to the 7y, that's just a number with respect to x. So its derivative is 0. Negative 143, we know that derivative, that's 0. Okay, df dy is going to be, okay, the derivative of x squared with respect to y will be 0 because x squared is a constant. E to the 7y, its derivative will be 7e to the 7y. Okay, and okay, those are the only two partials that they were asking for. Okay, number 2, gy, that's a partial derivative of g with respect to y. Okay, we're going to need to observe the chain rule here. We're going to take the derivative of the outside, leave the inside the same, and then take the derivative of the inside with respect to y. Okay, in this case, x, it's like 5, right? The derivative of 5y squared with respect to y would be 10y, so the derivative of this will be 2xy. We multiply that on the outside. Okay. And then gyy, I'll need to take the derivative of this with respect to y, and this will incur product rule. So I'm just going to look at it as product here, product there, right? So I'm going to say derivative of negative sign is negative cosine, leave the inside the same, then multiply by the derivative of the inside, which we determined was 2xy, and then we still had that 2xy because we're leaving it the same for the product rule. Then we're going to leave the negative sign the same and take the derivative of 2xy with respect to y, which is going to be 2x. Okay, so minus sine of xy squared multiplied by 2x. Okay, and that's where the product rule would come in with partial differentiation. Okay. Now here we've got u depending on s and t. Okay, us is going to be 2 plus 0, because this does not depend on s, therefore it's constant, and the derivative of a constant 0. Okay, ust, well, I don't see any t's in here, so this derivative is going to be 0. That one's nice and easy. Okay, dvdh, that would be, okay, the derivative of this thing with respect to h, and plus 0, because this thing has no h's in it. So this would be 2/9 of h plus 4 to the first power, times the derivative of h plus 4 with respect to h, which is going to be 1. Okay, now this would be taking the partial of v twice, first time with respect to h, then with respect to k. So I'm taking the derivative of this with respect to k. That's 0 because I see no k's in the formula. Right, number 5, x divided by y. Okay, this one, you might be best off considering this to be like x times y to the negative 1, right? So I'm going to say dz dx is, well, this is just 1 over y times x. Okay, and if it was 1 over y, it's a constant, like 5. If it was derivative of 5x, it would be 5, so this is just going to be 1 over y. Derivative of z with respect to y, okay, that's the derivative of y to the negative 1. That's, I think, negative y to the negative 2, still multiplied by that x because it's a constant. And then now the second derivative of z with respect to y both times, well, I'm just going to take the derivative of this with respect to y, and that would be positive 2y to the negative 3, and still with an x there. Okay. Oh, I have not used up this paper. Just fold it. That'll be all right. Number 6, okay, 10x times sinh of 1/5 of xy. Okay, if you didn't hear, and I think I told most of the classes in the lesson, but the derivative of sinh is cosh, hyperbolic sine, hyperbolic cosine. If you don't know anything about these, then, I guess feel free to skip this one. It doesn't matter. AP exam already happened. No skin off my back. So fx, this has x, that has x. I need to use product rule. Okay, so I'm going to say that's 10 sinh of 1/5 xy. And that was taking the derivative of that one, leaving that one the same. Then I'll leave 10x the same, and I'll take the derivative of sinh of 1/5 xy. So I will take the derivative of the outside while leaving the inside the same. And I'm taking with respect to x, so the derivative of 1/5 xy with respect to x is just going to be 1/5 y. Okay, I think I think I'm going to rewrite this a little bit to make this a little easier to look at, and because I need to take fxy I don't know if I told y'all that fxy is the same as fyx. This one might actually be easier to find fyx than fxy, but whatever. I'll just do it the way it says. You're just getting started on this one, so. Okay, when I take 10 and divide by 5, I'll leave 2xy, cosh of 1/5 xy. Okay, fy is going to equal, okay, well 10x is a constant, so that'll still be there. Okay, then taking the derivative, this is the only thing that has y in it, so taking the derivative of the outside while leaving the inside the same. And then taking the derivative of the inside with respect to y, well, the 1/5 x is a constant, and a constant multiplied by y, well, its derivative is just the constant, so that would be 1/5 x. Okay, now thinking, yeah, that's equal to 2x squared cosh 1/5 xy. Oops. Okay, and then fxy, I'm going to take the derivative of this with respect to y, so that would be 10 times hyperbolic cosine of leave the inside the same, and then take the derivative of the inside with respect to y, that would be 1/5 x, and I'm not going to simplify this. Okay, fxy, this is going to involve product rule. All right, take the derivative of the first factor first, leave the second factor the same. Then I'm going to add in, and I'm sensing I won't have enough room, so I'm going to go down here, and I will leave the first factor the same. Take the derivative of the second factor. Now the derivative of cosh is sinh, so I'll take the derivative of the outside, leave the inside the same. And multiply by the derivative of the inside. I'm taking fxy, so the derivative of the inside with respect to y would be 1/5 x. And this will be more than enough for this problem, right? Those are expressions for fx, fy, and fxy. Okay. Number 7 is f of x divided by y, okay, where f is kind of unknown, but we know it has a derivative. Okay, so dz dx is going to be, I take the derivative of the outside while leaving the inside the same. And then I'm going to take the derivative of the inside with respect to x. Okay, so just like up before, this is x times 1 over y. 1 over y is a constant, so it'll just be times 1 over y. And then this one, same deal. I take the derivative of the outside, leave the inside the same, and then multiply by the derivative of the inside, which is where we are going to say, all right, that's the derivative of x, y to the negative 1 with respect to y, so it'll be negative x, y to the negative 2. And that's dz dy. Okay, and then t of x, y, and z. Yes, this can happen. We can have a function depending on 3 variables. We can have a function depending on as many variables as we want. We can still take partial derivatives with respect to any one of the variables the output depends on. Okay, so tz, quotient rule. Oh well, bottom times the derivative of the top with respect to z. That's going to be 0 minus 3z squared. Minus the top times the derivative of the bottom with respect to z, which is going to be cosine of y squared z, times the derivative of the inside for the chain is, okay, with respect to z, that's just going to be y squared. All divided by the bottom squared. So that would be sine squared y squared z. Okay, and tx, well, that would be way easier. Okay, so if you could view this as like e to the xy divided by that sign minus z to the 3 divided by that sign, and z to the 3 divided by the sign, that doesn't depend on x, so it's not contributing anything. Moreover, this 1 over sine of y squared z, that's constant with respect to x. So I know that I'll have 1 over sine of y squared z times the derivative of e to the xy, which is just going to be e to the xy, times the derivative of xy with respect to x, which is going to be y. And then that'll be it. Okay. That's all of those kind of repetitious ones. Okay. Here they're going to show you how to write the equation of the tangent plane. The tangent plane to f, it looks very much like point-slope form from when we learned how to write the equation of a tangent line in AP Calculus. So what we're going to do is we're going to plane tangent to xy squared. Okay, well my point is now going to have 3 coordinates. It's going to be 2, 3, and f of 2 and 3. Well, f of 2 and 3 is going to be 2 times 3 squared is going to be 18. Okay. The partials, the derivative of f with respect to x, we're considering y squared to be a constant. So if this was like 5x, the derivative would be 5, so I'm going to say that derivative is y squared. And then the derivative of f with respect to y, well, that'll be 2 times x times y to the first, because we treat x as a constant that time. Then we need our partials at the point, so fx of 2 and 3, fx with x equals 2 and y equals 3 plugged in, that's going to be 9. And fy with 2 and 3 plugged in, that would be 2 times 3, wait, 2 times 2 times 3 is 12. Okay. And now my equation is going to be, I'm just going to copy right off of the general form, is z minus z0 is equal to fx times x minus the x coordinate of the point we have, plus fy times y minus the y coordinate of the point we have. Okay, there you go. You can do it. You can write the equation of a tangent plane. You can do anything in multivariable calculus. I'm telling you. Once you get through a single variable, it gets way easier. Okay, once you just provided you know how to do a derivative of an integral, and so double integrals, that'll be in the next video. Thanks for watching.